let's say we have some chloroethene here, and you wouldn't have to call this 1-chloroethanine, because if you just go with chloroethene, there's only one way to draw this. And the common name for chloroethene is vinyl chloride. So let's say we have a bunch of chloroethene molecules along with or mixed with some hydrogen chloride. And I've drawn all of the valence electrons for the chlorine atom, and I've drawn a little magenta electron, the one that the hydrogen atom brought to the table. So we've seen something like this before. What is likely to happen? Well, maybe one of these carbons is willing to give up an electron. That electron goes to the hydrogen because this electron's already being hogged by the chlorine, so this hydrogen has a partially positive charge. Chlorine has a partially negative charge. So that electron would be attracted to the hydrogen. Then this electron can be completely hogged by the chlorine. And if we had to decide which of these carbons is more likely to give up the electron, you just have to say which one is bonded to things that it can share electrons a little bit with. This carbon's only bonded to hydrogens. So it's already hogging their one electron each. There are no more electrons to share with it. This guy's bonded to a chlorine. So the chlorine has a bunch of valence electrons. It might be able to share it a little bit with this carbon if this guy became a carbocation. So this guy will lose an electron. This carbon will form the bond with that hydrogen. So let's draw it out. So let's say this carbon's electron is that blue thing right there. It will, well, we could draw it like this. It goes to the hydrogen, and then the hydrogen's magenta electron goes to the chlorine. This is just a plausible mechanism. Now, once that happens, what will our setup look like? What will it look like? We'll have this carbon over here bonded to two hydrogens. It has its single bond to that other carbon that just lost its electron, which is bonded to a hydrogen and a chlorine. And now this carbon on the left, it is now bonded to the hydrogen. That electron went to the hydrogen and it formed a bond with it. So then it forms a bond. So that little blue electron is at this end of I want to make it blue. That little blue electron is at this end of the bond, and it is now the hydrogen's electron. And that magenta electron went to the chlorine. So now it is a negative ion. It is a chloride ion. So we have a chloride ion. It has its standard 7 valence electrons that it started off with, but now it took that magenta electron from the hydrogen. And so now it has 8 valence electrons. It gained an electron. It now has a negative charge. This guy over here lost an electron. He now has a positive charge. Now, the next thing that you might expect to happen if we just followed the pattern of the last several videos is you would say, hey, this guy will now take an electron from the chlorine, which is or the chloride anion, I should say, which is completely plausible. But there's also a bunch of the chloroethane. This isn't the only molecule of chloroethene. I should say chloroethene, not chloroethane. Chloroethene sitting around. So let us throw another one of those in there. So we have more molecules of this. So he could take an electron from the chloride ion, or he could take an electron from this guy over here. Remember, this guy, just like this guy, who was this guy is okay. It doesn't require a super amount of energy to make this guy lose his electron. He's bonded to other things that are willing to share with him a little bit. Maybe he's willing to lose his electron as opposed to the chloride ion. So this guy has, let me draw it in. So this end of this bond is green, and then this goes and bonds with this carbon. So this will be a long bond right here. So this goes and bonds with that carbon, essentially giving that electron to that carbon. And then what will our setup look like? So after that happens, we'll look like this. I probably should have copied and pasted this from the get-go. Actually, let me do that let me copy and paste this. So now, let me just copy and paste this whole thing. Nope, that's not what I wanted to do. Let me select it again. All right, copy and then paste. There you go. So then we have that thing, And then let me redraw what I had erased so that I could copy and paste. And then we have this guy went over to this carbocation. So he's no longer a carbocation. So let me erase this, because now he's gained an electron. He gained that green electron right there. He gained that green electron. I'll just draw it right there. And now he's formed a bond with this carbon. And I don't know, I'll make it blue just so we know which carbon we're talking about. He's formed a bond. This bond now moved over to that carbon because the electron went with it. So now that bond is to this carbon right here. That carbon right over there, which is bonded to two hydrogens. Two hydrogens. And now has a single bond to the electron that gave up the carbon. Has a single bond to that character right over here, who is bonded to a hydrogen and a chlorine. A hydrogen and a chlorine. And since he now lost an electron, he now has a positive charge. So if you look at this setup right here, it looks very similar to this setup, although we've added one more vinyl chloride to the mix. And the one that we added lost its electron, or this carbon lost its electron, and now it's a carbocation. So what could happen next? Well, we have more of this vinyl chloride sitting around. We have more of this vinyl chloride sitting around. Let me draw another vinyl chloride. So I have a carbon, the hydrogen, a hydrogen, and then it is double bonded to a carbon, a hydrogen, and a chlorine. And let me copy and paste this. I think you see where this might be going, how this could keep on going and going and going. So copy, and then I just copied that for now. So what's going to happen now? We have this guy could go and give an electron to this guy and form a bond. Or we could have the same process happen over and over and over again. So this, let me get my pen tool going. So this electron could be given to this carbocation right there. So this electron can be given to that carbocation right there. And then what happens? Well, if that happens, then we're going to get, I'll move to the left now. We have our original molecule. I'm going to run out of space soon. We have this original molecule, and now this guy is bonded to that. So this carbon, this carbon right here is going to be this carbon, and now it is bonded to this guy. It is bonded to this guy. That orange electron is now given to this guy who was positive. So he now has, let me make it a little bit neater. I could do a better job than that. So the carbon's here. The bond goes to this guy. He now has the orange electron. He no longer has a positive charge. He no longer has a positive charge. He's got all of his valence electrons now. And now this guy is bonded to two hydrogens. Two hydrogens. That guy is bonded to two hydrogens. And he has a single bond, this single bond right here, to the carbon that just lost his electron, who's bonded to a hydrogen and a chlorine. And because he lost his electron, he now is the carbocation. He is now a carbocation. So I think you see where we're going. We can just keep adding and adding and adding to this chain of vinyl chloride. So if this process just went on and on and on, we could make it like this. It would look something like this. Let me see how well I can draw it. So it would look like this. So this is a CH3, so I'll just draw it as H3C. And then this is bonded to a carbon that is bonded to a, well, maybe I'll call it a CH, which is bonded to a chlorine. So we're that far in the molecule. And then we have, let's see, the part that repeats. This part right here is going to keep repeating. That part right there is going to keep repeating. So that part right there, and I'm going to do it like this. So I'm just going to draw one of them. So you have a CH2, that's that right there. And then connected to a CH, which is that right there, which is connected to a chlorine. And so that part right there will keep repeating. And then maybe the very last one, so you have this guy right here, maybe the very last one that joins on. I mean, this can happen millions of times. I just made it happen 2 or 3 times. It could happen millions of times and form a super long chain, or a polymer. And where what we are describing in this video is actually a polymer that you have probably dealt with at some point in your life. In fact, I guarantee there's some of it in your house right now. So then we'd have that part right there, and we could just make that as CH2, CH, Cl, Cl, and now the way we've drawn it, it's a carbocation, but maybe we've run out of all of the vinyl chloride molecules, or we could also call them chloroethene molecules. And now finally, when everything's said and done, this last guy, since he's run out of vinyl chloride molecules to take their electrons from, he now finally takes it from the chlorine. So you can imagine, after this happens many, many times, so this repeats many times. After this repeats many times, then finally one of these electrons from the chlorine, go to that final carbocation because they've run out of other vinyl chlorides, and then he attaches right over here to the chlorine. Now, this is called, so when we say that this might happen, this repeats many times, you might write an N here just to show that it repeats many, many times. If you know how many times it means, if you know that there were, I don't know, if you know that there were 1,000 molecules here, you would write 1,000 repetitions. But this is called a polymer. Polymer. And the name for this molecule right here is, each of these units is vinyl chloride, right? Vinyl chloride. Vinyl chloride. I guess the official name is chloroethene, but the typical name, the one people actually use, is vinyl chloride. That's for each of these units. It's a polymer. We have many of them, so we'll put a poly in front of it. So this molecule right here is polyvinyl chloride, or, and now I think it'll ring a bell, or PVC for short. And you've probably heard of PVC piping. It's what most people have for their plumbing. It's those plastic pipes. And that's what it is. It's polyvinyl chloride.